Hello, today we're looking at example 5 found in section 8.4 of your pre-calculus part 2 textbook. This is found on page 851. In this particular example, we want to show you how to use an inverse of a matrix to solve a systems of equations. As you can see here, we've been given a system of equations right here that of course we always turn into a matrix. And so it looks like this written as a matrix equation. You list all of your coefficients, of course. So 1, negative 1, 1, 0, negative 2, 1, negative 2, negative 3, 0. And then, of course, because you have x, y, and z, they're listed down this way. And the reason they're listed this way is to make it compatible with the size of the other matrix. Remember, the inside dimensions have to match up to be able to multiply. And then the three numbers or the constants over on the right is ended up calling the constant matrix. Now, to be able to solve a matrix is pretty easy. If I want to find what x, y, and z are, which is called this, just a giant X right here, you're going to find the inverse of matrix A and then multiply it by matrix B. Okay? So right here is the answer to, that is the inverse of matrix A, that they're going to end up multiplying by matrix B. But I wanted to show you, in case you didn't know, kind of how that happens. You would go to your calculator and you would press second, and then this button right here, if you can see the word right there, it says matrix. So you're going to hit matrix. Now you're going to edit because you're going to have to put the original number in. So if you'll look at matrix A here, and go over to edit and then press enter. I've went ahead and loaded, this is the original matrix, the 1, negative 1, 1, 0, negative 2, 1, negative 2, negative 3, 0. Okay. Now at the same time, go back and hit second matrix again. I want to scroll over, but I also want to scroll down to matrix B, and I want to show you that. So when I press enter here, that is the constant matrix that you see over there on the right, which is 2, 2, negative 5. All right. Now, what you're going to do here, and they show you that they found the inverse, but they didn't show you how they found the inverse. What you're going to do, always do that to clear your screen, second and quit. You're going to do second matrix. And this time, instead of edit, you're going to just literally click on enter because you're going to multiply matrix A. You're going to take the inverse of that. Inverse is this button right here, right below the matrix. So if you hit that, the little -1 will pop up. So you've got A to the -1. Then you're going to do second matrix again, because this time we put the constant matrix, which we're calling B, here. And so you're going to multiply by matrix B. And when you do, you end up, it just goes ahead and does all the dirty work for you, all the hard work for you. You're going to end up with 0.5, negative 0.5, and positive 1. Okay, so let's flip back over to this screen here, and you can see right here that that's exactly what they got. 1/2, negative 1/2, and positive 1. Okay, and I just wanted to show you that. Used to 3x3 matrices, if you're doing them by hand, can take quite a bit of time. But once you learn to turn them into a matrix by doing this method first, and then taking the inverse of this one and multiplying it by this one, which is what this is saying right here. Take the inverse of, because this is always considered A, as you can see right there, and this matrix is always considered B. All you have to do is take the inverse of A and multiply it by B, which I showed you how on the calculator, and you will ultimately get to your three answers. Remember, the top one would represent X, the middle one represents Y, and the bottom one represents Z. So all they did was rename them in a set notation, 1/2, negative 1/2, and 1, representing the X, the Y, and the Z. Okay? I hope this will prove to be very helpful and kind of a great shortcut for you as you're solving systems of equations. The good thing about this is it doesn't matter how many equations you're trying to solve at one time, as long as it's, of course, a square matrix like 4 variables and 4 equations, or 5 variables with 5 equations, that kind of thing. You could get as big as you wanted, whereas we were limited the other way. That would have taken an enormous amount of time to be able to do. So anyway, good luck, best of luck on this. Hope this was helpful.